JavaScript classes offer a structured and organized method for creating objects that share properties and methods. They serve as a fundamental component of object-oriented programming in modern JavaScript. Here we can see an example of a class called car, which has a constructor that takes in brand and model, and a method named start. Classes in JavaScript can be declared in two primary ways. The first way is called class declaration, which involves using the class keyword followed by the name of the class, such as rectangle here. Inside the class, you can have a constructor which takes in width and height, and a getArea method which returns the area of the rectangle. The second way to declare classes is called named class expression. It involves assigning a class to a variable, such as circle here. Note the class keyword followed by a class name, and again a constructor and method for calculating area just like before. Class expressions provide more flexibility in how you define classes. An anonymous class expression involves declaring a class without explicitly naming it. Here the class is assigned to a constant variable called shape. It has a constructor that takes in type and a describe method. Another pattern is the class factory pattern. This involves creating a function such as createLogger here that returns a new class definition. The returned class, logger here, can then be used to create specific instances of objects. Constructors and methods are essential for defining the behavior of classes. A constructor, like the one in the user class here, is a special method that is called when a new object of the class is created. It's used to initialize properties of the object. In this example, there is parameter validation and new date object creation. Methods like add, version, and fetch data in the calculator class define the actions an object can perform. Methods can be instance methods, getter methods, or asynchronous methods. Class fields provide a way to define properties directly within a class. Public fields are declared directly inside a class, such as name, price, in stock, created at, and ID here. These fields are automatically added to the object when it's created. You can also use computed fields where the name of the property is dynamically generated. As shown in data store here, this also allows for more complex field declarations, including usage of expressions to generate the keys or values. Private members enhance encapsulation by restricting access to certain fields and methods from outside the class. Private fields and methods are denoted by a hash symbol, such as the hash balance and hash transaction fields, and the hash validate amount method in the bank account class. They can only be accessed from within the class itself. Private accessors such as getters and setters can be used within the class to control access to the private members. As shown in the user class example here, you can define a private getter called hash full name. Static members are associated with the class itself, rather than with instances of the class. Static fields such as pi and e in the mathUtils class are shared among all instances of the class, and can be accessed using the class name itself. Static methods such as square and cube here are also called on the class directly and do not require an instance of the class. Private static members, such as hash connection and hash connect in the database class here, help in controlling the state and behavior of the class itself. Inheritance allows you to create new classes that inherit properties and methods from existing classes. Basic inheritance is achieved using the extends keyword, as shown here, where the class dog extends the class animal. This means that dog inherits all the properties and methods of animal, and can also override them, such as the speak method here. The super keyword is used in the constructor of the child class manager here, to call the constructor of the parent class employee. Advanced inheritance enables more complex class relationships and code reuse. Method overriding allows a subclass, such as electric car here, to provide a specific implementation of a method that is already defined in its superclass vehicle. You can call the method of the parent class using super.method name. An inheritance chain, as shown in the example of the button, user interface element, and component classes, allows for a hierarchy of classes that build upon each other. Mixins provide a way to compose behaviors into classes by adding methods and properties from different sources. A Mixin factory function, such as the logger Mixin here, is used to create the Mixin. It accepts a base class as an argument and returns a new class that extends the base class with additional functionality. To use a Mixin, you call the Mixin with the base class, as shown here with the logged user class, allowing for functionality to be composed into it. When designing classes, it's important to adhere to best practices for maintainability and scalability. The single responsibility principle states that each class should have one specific purpose. This is illustrated by user authentication class, which focuses only on authentication logic. The immutability pattern, shown here in the configuration class, ensures that once an object is created, its state cannot be modified, promoting stability and predictability. In addition to the basic design principles, there are advanced patterns and techniques that can further improve class design and code quality. The factory pattern provides a centralized method for creating objects. This way you can decide which concrete class to instantiate based on configuration provided. As shown here with the API client class. Proper error handling is crucial for creating robust classes. This can be achieved by using try-catch blocks, as shown in Data Validator, and throwing custom errors to provide more context and information. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.